way. Graham walks 8 blocks from his home to the library. So we'll draw. He walks 4 blocks east, so here's his home to the library. 4 blocks east and 4 blocks south. So there's a map, top view of the map. And how many ways can Graham walk to the library? So the first thing he could do is say, well, what's a possible path? He could go 4 blocks south first and then 4 blocks east. He could also go this way and down, or this way and down, or he could go this. But he never loops back, right? He's always going 4 blocks south, 4 blocks east, because he knows where the library is and he doesn't get lost on the way. And so what we just have to do would be to think of all possible routes. And is anyone counting? Did I miss any? Did I get this one? Or this one? How about that? No, I haven't done that one. Oh, I haven't done this one. Or this one. Oh my goodness. How many was I at? Of course, no one was counting. And would this technique be very useful? Probably not, because it would be very easy to lose count and figure out and not remember which one we did. So we got to figure out a way to count this. And we also have to figure out, why is this in the identical objects? How is this a Mississippi question? Well, if we look at one route, let's say we take the easiest one to get there. Okay? So this route could be represented by going east, east, south, 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 east, east. Does that make sense? See why that's an easy route to get there? Okay? Now, what would another route look like? Another route could look like this. Well, what would that be? That would be south, and then east, and then south, and then east, and then south, and then east, and then south, and then east. And all of a sudden we realize that every unique route is just a rearrangement of these letters. How many rearrangements are there? Well, it's a Mississippi question. Because if every direction he walked was different, it would be 8 factorial. But we have 4 souths and 4 easts. And so we have to divide out those repetitions, because if I switch these 2 s's around, that's still the same route from his house to the library. So we can solve this question with identical objects by recognizing that a route can be e's and s's, easts and souths, to get there, and then figuring out how many arrangements of that are possible. Now, another way is just to count it. And you can count it by noticing a pattern. So here I am at home, and if I wanted to get to this block, and all the way we're never going to be confused and go, oh, I have to go backtrack, okay? We're always going to go directly to a path. How many ways could you get to that intersection from home? How many pathways are there? Just one, right? Does that make sense? Same thing, there's going to be one pathway there. Can you see how many pathways to this intersection? You can probably visualize them. One here, one there. There would be 2 to get to that one. Now this is a tricky one, sometimes right at the beginning. How many pathways are there to that point? There's still only one, right? It's 2 blocks. Sometimes you want to put 2 because you walk 2 blocks, but the only pathway is that straight line. Same thing, there's only one pathway to that intersection and one pathway to that intersection, one to there, one to there, one to there. Because the only pathway, if I want to get there without backtracking, is to walk straight there. There's no other way to get there without backtracking. One unique path. How about this point? Can you count them all? There'd be 1, 2, 3. Similarly, this one will be 3. I'm going to give you a couple of numbers. I'm going to tell you this one is 4 and this one is 4. And I want you to tell me what this one is and see if you can figure out a pattern. That one's not 5. It's not 9. Close. Good idea. Add the 2 corners, it's 6. Now, adding the 2 corners, if there's 3 routes here, and there's 3 routes here, to get to this 6, you could take any of these 3 and then go that way, or any of these 3 and go down. And putting those together would give you 6 routes. So, does it make sense that this one will be 5? Because there's 4 and 1 on the corners to get to 5. To get to this one, you can either take the 6 or the 4, which will be 10, 10, 5. This one will be 15, 20, 15, 35, 35. And I don't know if anyone's calculated 8 factorial over 4 factorial, 4 factorial, but it's 70 as well. Now, the counting thing is going to come up again later in this unit in a different form, so it's kind of interesting. Obviously, the identical objects, when it's a straightforward grid, is probably the easier way to go about it. However, the counting way, you know, not all city blocks are like this, right? Some of them have like ponds, and that takes out a certain area that you can't go by. And maybe Graham, he always walks to the library and always picks up a date on the way, because the library is a perfect place to take a date, especially for this class. You can just sit and be quiet and not have to talk, and then go home after an hour of reading books or whatever you need. So, there's Sally's house. Now, how many ways can Graham walk to the library if he has to pick up Sally on the way? Okay? And he's not going to backtrack. So can you see now that he's never going to go to this intersection, those ones are going to be out. He's never going to go down this far because then he'd have to backtrack up. So these ones are out. How many ways can he get there? Well, we start off the same way, saying, well, starts there, there's one way there, 1, 1, 1, those straight lines. There's going to be 2 ways that he can get to this point, 3 ways that he can get to this point, 4 ways that he can get to this point. How many ways can he get to this point now? Again, if you add up the corners, what's 3 plus nothing? Just 3 ways to get there. Because he can go all these 3 paths, and then just adding 1 extra line doesn't add another route. How many ways can he get to Sally's house? 7 different ways to get to Sally's house. Then straight down would be 7 plus nothing, 7 ways. This one also will be an X, because he won't go there, because he's gone there, this one. So this one too will be 7. This will be 14. This one will be 7. And that would be 21. So now if he's picking up Sally on the way to the library, and a lagoon appeared overnight, then there would be only 21 ways that he could get there. And for this one, the counting works better because we can't just directly go from easts and souths and figure out the order, because some of them are X'd out. Okay, we're going to do one more question before I get you to work again, but the question for this one is number 12.